Hello everyone, welcome to the session of class 9 mathematics, and I am your Anu for mathschool.1. Last class we have been seeing some algebraic identities, and I have listed out some algebraic identities for square and cubic identities too. Okay, so let us now understand these identities through some problems. Okay, so as and when we do problems, we'll understand what are the identities we use in them, and then later on, after solving some problems, we'll try to factorize expressions using these identities. Okay, so now let's get started. Algebraic identities is what we are going to see about for the chapter Polynomials, chapter 2. Okay, so now the first problem is 2x minus 1 by x the whole square. See, whenever I do a problem like this, just observe what type of identity it follows and justify your answer with the identity. So okay, so now this is just like a minus b the whole square. So I do the expansion here so that I don't do any mistakes, or I can avoid mistakes by writing the identity it follows. So now a is 2x and b is minus 1 by x, or b is 1 by x. So now a square plus b square minus 2 into a into b. So what is 2x the whole square? It is 4x square plus 1 by x square. X gets cancelled, so you have minus 4 here. So this is how we write 4x square plus 1 by x square minus 4 will be your answer for the given problem. So it follows a minus b the whole square identity. Now the second one is 2x plus y 2x minus y. So when you see this, you understand that this follows a plus b, a minus b into a minus b identity, which gives you a squared minus b squared. So you can just apply readily. So 2x the whole square minus y squared. So this becomes 4x square minus y squared. So this is your answer. Okay, do you understand? Yes. The next problem is next one is 0.54 into 0.54 minus 0.6 into 0.46 into 0.46. So now we have seen in identities there were literals or there were variables. And now in place of variables, constants are given, so that we'll be able to get an answer for it, isn't it? Now when we observe, we have similar terms here and similar terms here. Let me rewrite so that you'll be able to identify with the identity. See, 0.54 squared minus 0.46 squared. So this just resembles a squared minus b squared, which is equal to a plus b into a minus b, isn't it? So we need to simplify. So we rewrite this. What is that? A squared minus b squared is a plus b into a minus b. So what is 8 plus b now? 10, 1. So this becomes 1 now. And what is 54 minus 4, 6? 14 minus 6 is 8. So 0.08. So 1 into 0.08 is nothing but 0.08. That's it. So this is your answer. So do you understand? 0.08 is your answer for this. 0.54 into 0.54 minus 0.46 into 0.46. See how easily we have obtained the answer without multiplying, isn't it? Without multiplying twice and subtracting and all. We have got the answer directly. So this is how we use identities to simplify problems. And the next one is 104 into 96. Now see 104 into 96. These are some two numbers which where we need to apply the identity. So for us to get the identity, to apply the identity in the problem, first they should be converted into a similar pattern, okay, to apply identity. So let us see some relation between these two numbers. That is, this is 104 and this is 96, and this is 100 plus 4 and this is 100 minus 4, isn't it? So that's it. We need to find some relation between the numbers so that we can apply the identity. See, we have a plus b and a minus b. Because a is same, b is same, we have a plus b into a minus b is nothing but a squared minus b squared, isn't it? So 100 squared minus 4 squared. See how simple it is. 100 squared is 10,000 minus 16. What is 10,000 minus 16? 9,999. For 99, see, this is 10,000, isn't it? So 9,984. That's it. So this is your answer. 10,000 minus 16 will give you 9,984. Do you understand now? How do we simplify sums using identities? Now the next one is 105 into 106. So 105 into 106. Here too we need to understand the relation between the two numbers. So the two numbers can be represented by 100, 100 plus 5 into 100 plus 6. So what does this this term, whether it is similar to some identity, we need to see. Yes, because x is same here, that is 100 is same here, and this has to be a and b now, so that we can apply the identity x plus a into x plus b is equal to x squared plus a plus b into x plus ab. So I told you, whenever you do a problem like this using algebraic identity, you justify your step. Whatever you are going to do, you justify that with the algebraic identity with which you are going to solve the problem. So this becomes 100 squared, that is x squared, 100 squared plus, what is a plus b, 5 plus 6 into x, that is 100, plus what is ab, that is 30. So the answer is 10,000 plus 5 plus 6 is 11, 11 into 100 is 1100 plus 30. So what is the answer? See, 1100 plus 10,000 will be 11,100 plus 30, 11,130. Okay, so this is your answer. See how easily we got the answer for 105 into 106. So that is the use of algebraic identity. Next is, our next problem is sixth one. If x minus 1 by x is equal to minus 1, find x squared plus 1 by x squared. See, I told you we got the intermediate results while doing algebraic identity, while learning algebraic identities, isn't it? That is x squared plus 1 by x squared resembles a squared plus b squared. So what is a squared plus b squared? For that you have two results, isn't it? That is a plus b the whole square minus 2ab, or a minus b the whole square plus 2ab. That depends upon the sum I told you at that time. So now the sum is x minus 1 by x. So you need a minus b. Okay. So we take that formula, a minus b the whole square plus 2ab. So write it here. A minus b the whole square is x minus 1 by x the whole square plus 2 times x into 1 by x, because a, b is x and 1 by x, and this will certainly give you x squared plus 1 by x squared. That is what is asked, isn't it? That is a squared plus b squared which is asked. Now substitute the value for x minus 1 by x here. That is minus 1. Minus 1 the whole square plus x get cancelled, that is 2. So that is equal to minus 1 the whole square is plus 1 plus 2, which is 3. So 3 is your answer. X squared plus 1 by x is nothing but 3. Isn't it? Do you understand this step? Okay. Now let us extend our knowledge of x squared plus 1 by x squared to find x power 4 plus 1 by x power 4. Okay, so how do I find x power 4 plus 1 by x power 4? That is, you should just understand how do we get power 4. Now, when we had just a and b, okay, when we had a and b, we got a squared and b squared, isn't it? A squared plus b squared. So, if I square a squared and b squared, I'll get a power 4 and b power 4, isn't it? So, that is what we need. So, we write a squared plus b squared the whole squared is equal to a power, see, instead of a and b, we take a squared and b squared, because by which we get a power 4. A squared the whole squared will be a power 4 plus b power 4 plus 2 times a squared b squared, or ab the whole squared. But now here we have x minus 1 by x, isn't it? So I write a squared minus b squared the whole squared. This can also be as plus 4, okay, by b squared minus 2ab the whole square. You have these two formulas. See, a squared ab the whole square. You have these two formulas. Now we need to substitute this. Since we have already obtained a squared plus b squared is equal to 3. Okay, since we have already got a squared plus b squared is equal to 3, that is x squared plus 1 by x squared is equal to 3, we have already obtained, isn't it? So we will take this formula. Do you understand? So this is not needed, we take that formula. Now, from this, what is a power 4 plus b power 4 is equal to a squared plus b squared the whole squared minus 2ab the whole square, isn't it? So this is what we need to get. So what is a power 4 plus b power 4 in our problem? X power 4 plus 1 by x power 4, which is equal to, what is x squared plus 1 by x squared? We have got this as 3. So 3 squared minus 2 times, what is a, b here now? What is a and b? Anyway, it's going to get cancelled, isn't it? Squared the whole squared is nothing but we cancel them. Okay, so 1 squared is just 2, 2 into 1 squared is just 1. So we have 9 minus 2, that is 7. Do you understand? So x squared plus 1 by x squared we had 3. And how do we get x power 4 plus 1 by x power 4? We use this identity, that is, instead of a and b, we use a squared plus b squared the whole squared is equal to a power 4 plus b power 4 plus 2 into ab the whole square. That is, we know a squared plus b squared, that is x squared plus 1 by x squared. We already know, we have just obtained the result, isn't it? We had 3 there, so we can substitute here. That is, x squared plus 1 by x squared is 3 for us, and a into b is x squared into 1 by x squared gets cancelled. So x power 4 plus 1 by x power 4 will be 7. Do you understand? So this is one of the important problems we have in this chapter. So please do follow the steps. Please do follow the path by which we get x power 4 plus 1 by x power 4. So that should be obtained from x squared plus 1 by x squared. Now, the next one we are going to see is a similar problem, but it is a reverse problem. The reverse of what we did now. We had x minus 1 by x in the question, and we were asked to find x squared plus 1 by x squared and x power 4 plus 1 by x power 4, isn't it? Now in this problem, in the 7th problem, you have x squared plus 1 by x squared is equal to 66. You need to find x minus 1 by x. So this is just like having a squared plus b squared, and you need to find a minus b. So that follows the identity a minus b the whole squared is equal to a squared plus b squared minus 2ab, isn't it? So from this, a minus b will be square root of a squared plus b squared minus 2ab, isn't it? Because this is a minus b the whole square. Okay, so first we'll do x minus 1 by x the whole squared is equal to, a squared is x squared, b squared is 1 by x squared minus 2 times x into 1 by x. So the x gets cancelled, and for x squared plus 1 by x squared you have 66 here. So 66 minus 2 is 64. Now what is x minus 1 by x here? See, x minus 1 by x the whole square is 64. So x minus 1 by x is root of 64. Do you understand? I am removing the square, so I find square root on both sides. So square root of square is just x minus 1 by x, that is 64. So I have 8. So I have obtained x minus 1 by x is equal to 8. Now do you understand? How do we go? The reverse of the problem which we saw the previous problem, the reverse of it is getting the answer, getting the question from the given result. You understand? So this is one type of problem. Now with this we have solved up to 7 problems. With this I have stopped this class, I end this class, and in the next class we will be seeing some more problems using identity, so that you will have a clear idea about identities. Okay, until then it's bye from Anu from ALGEBRAIC.1. Thank you.